In this video, we're going to look at similar triangles. Two shapes are said to be mathematically similar if their shape is the same, but their sizes differ. This is different to congruent or congruent shapes. Congruent shapes are exactly the same in terms of their shape and their size. I'm going to start off now with a square. So if we have a small square and a large square, we can say that their side lengths are in the same ratio. These are proportional. So if we put on here that this was going to be 2 and this was going to be 4, we've got 2 and we've got 4. This now is simply a scale factor enlargement of 2. So we have the same angles and we have proportional sides. If I wanted a congruent square or congruent, we would have to have now the same shape and the same size. So if I put the 2 on here and 2 on here, and we'll label these up, we'll say that this one is going to be A, this one is going to be B, and this one is going to be C. So A and C are congruent. We can say that A and B are similar, and C and B are similar. Let's go ahead and draw now some triangles. Let's draw a right angle triangle. So if I have a right angle triangle, I'll put that one on, and then I will have one more, and I'll make this one slightly bigger. So all this is a scale factor enlargement. So let's say now, and I'll put this one on, this isn't massively accurate, but if we have our known 3, 4, 5 triangle, this one could be now the 10, 6, 8 or 10, 8, 6. We can see again this is a scale factor enlargement of 2. These are similar triangles. We can say that this angle is going to correspond with this one. We can say now that this one right here will correspond with this one, and of course we have the right angle. So the angles are the same, which sets the shape of this particular triangle, but the dimensions differ as it's a scale factor enlargement. If we wanted a congruent triangle, we would have to have the 3, 4, 5 with this one, or the 6, 8, 10 with this one. So let's go ahead and look at answering some questions. We're asked to find the two pairs of similar triangles and say which is the odd triangle. So what we've got here to begin with, the first 5, we've got now 2 known angles and we need to state which ones are similar. We know that the sum of the angles in a triangle give us 180, so this one is going to be now 80. This one, that's 130, so that's going to give me 50. That one is going to give me 120, so that would be 60. That gives me now 110, so that would be 70. And this one right here would give me 110, so that would be 70. If we just consider now, if these triangles have the same angles, they will just be scale factor enlargements of one another. So if we look at this one right here, we can see that that's 30, 70 and 80. That one will go with that one. Despite it being flipped over, it's still a similar shape. It even looks like it's congruent, but we can't tell because we don't have any dimensions. It might be a millimetre shorter. This one is going to go with this one, and then this one is going to be the odd one out. Once we have 3 set angles, the proportion now will be the same. So for example, now if I just drew another triangle, all I'm doing is drawing lines that are parallel to each of these. So let's put that on and something like that. That will be a similar triangle. I've set this angle at 70, I've set this one at 50, and I've set this one at 60. So similar triangles. Okay, let's look at the next set of questions. These look slightly harder. Some have 2 lengths and 1 angle. Some have 2 angles and 2 lengths. Let's look and start off and see if there's an easy pair to pick up. I'm going to focus now on these ones just here. So if I just focus on these. Now if I just turn this round slightly and point the 26-degree angle here, and I'll do it now, I'll just draw it below. What I'm going to have is something that looks like this. So I'm going to do this. Remember, these are not accurate. What I've got on here is a 26-degree angle. We've got the 26-degree angle just here, so let's put that on. That's going to be 26. I've got this side length of 8, and I've got this one of 10. We need to ensure that the sides, both the sides, are in the same ratio. So what we can see is that the 4 goes with the 8, we've got the 26-degree enclosed angle, and then we've got the 5 going with 10. Well, if I scale up from 4 to 8, that's going to be multiplying by 2. If I scale up from 5 to 10, that is also multiplying by 2. If these values now were not both multiples of 2, then these are not going to be similar. So that one will be similar with that one, and I need the angle to be in the same place. If we look at the others, the temptation here is to go with these two. But if we look, we don't have this side to work from. So if we look at this one, we got this 31-degree angle. We got 111 and 39, so let's just make up to the 180. This is going to give me now 31 degrees. So what I've got then are two triangles. I'm going to sketch both of these up below. So I've got this one, and it's going to look something like that. And then I've got this one over here, and I'm going to give it now the same orientation, or the way round that it goes, and we'll just put this on. So if I fill out the information, we're going to have this angle, which is going to be 31. So 31, that is going to be 6, that is going to be 4. This is going to be the 31, that is 9, and that is 6. These are similar triangles. If we look at the scale factor in this particular case, if we go from 4 to 6, that's a 1.5. We can see that these are also in the same ratio of 1.5. If you're unsure, you could go ahead and divide. So if you look at 9 divided by 6, that will give us 3 over 2, or 1.5. That now should be the same as 6 divided by the 4. We have to check that these are the same. Now what we can do with this one is look at the corresponding sides and angles. So from this I can say the following. I can say that this one right here, this angle, and I'll put it on here, will be corresponding with this one just here. So we can say it's this one, so putting that there, with this one. This one right here, and we'll put this on, is going to be now corresponding with this one just there. So we could say now that this side length, I know they don't look the same, but this one will be now corresponding with here. So let's be a bit cheeky here and just say, well, we know, and we'll say that this one here is going to be, let's say that this is going to be 15. Let's just go for 15. So what I need to do then is find this length right here. I know that's not accurate, but it just gives us some idea of what's going on here. So if this one is going to be 15, what do we have here? Well, this one is going to be scale factored down, so that is going to be 10. So ignore the fact that it doesn't really work, just look at the proportion. We're simply looking at proportion. So what we can say then is the following. It's going to be this one, this will be similar with this one, and we've got now the odd one out over here. So there we go, that's what we've got. Let's move on and look at some others. Here are 3 pairs of similar triangles. Answer the questions below for each pair. So let's start with this pair here. So this pair we're going to look at to begin with. So we've got some questions down here, and we can go ahead and put these on. So which side corresponds to AB? Well, if we look here, AB, we can work this out from the angles. If we look here, we've got now the double angle here, and we've got the single angle here, so that will be the line XY, or YX. We can see that this is set up quite nicely. Which side length corresponds to XZ? Well, if we look at XZ, well, that's that one. That, based on the angles, will be that one just there. Which angle corresponds to C? Well, we can see that Z. We can see that by the notation. Which angle corresponds to Y? Well, that's going to be A. If we had, for example, now let's say that this was going to be, we'll say that that's going to be 4 and that one's going to be 5. If we were told now that this one is going to be 6 and we wanted to find this length, which I'll just call this D for distance. What have we scaled it up by here? Well, the answer is 1.5. So what do I need to do here? Scale up by 1.5, and that would be 7.5. These, remember, are proportional. Okay, let's have a go at this one just here. I think this one looks slightly more challenging, so let's do this one. Okay, so what we've got then are these 2 similar triangles. So they're similar, they share the same proportions. We've got 3 angles that are the same, and we've got now the side lengths which are in the same ratio. So which side corresponds to AB? So here's AB. We need to be quite careful with this. Let's just put this on. That is AB. So if we look, it's going from a treble to the single, and that is going to be that one just here. Often the best way to think about this is being flipped over. What I'm going to do is just draw this below flipped over, because often when we're doing these questions it can help to look at it a different way. So what I've got then down the bottom, hopefully this all makes sense, I've got y here, so let's put y, and I've got z here, and I'm taking x and I'm flipping it up the top. So imagine this is your axis of symmetry and you're lifting x over and bringing it here. So we end up now with x here, we've got the double angle here, we've got now y down here with the treble, and we've got z as that right there. So we can see quite clearly from here that yz is going to correspond to AB. Which side corresponds to xz? Well, this is xz, we can see that is AC, as it's going between the double and the single notation on the angle. Which angle corresponds to C? Well, we've got the double, so that's going to be X. Which angle corresponds to Y? Well, that's going to be now the treble, which is going to be B. Don't be afraid in your exams to flip this over. Just go ahead and see what works for you. So if we said that this was going to be, let's say that's going to be 5, and this one is going to be, now let's make this 10. I mean, that's not accurate. And we were told now that this one was going to be 12. Then we can say this one is going to, of course, be 6. So that's all we're doing. We're looking now at proportional side lengths. Okay, let's move on. Right, what we need to do in these ones is find the value of x and y. Sometimes these are blindingly obvious and you can see that they're scale factored up. So on this one I can see that I've got a scale factor of 2, so all I'm going to do is multiply. That won't always be the case, so what we do is set up an equation. So let's first find y. There are a couple of different ways that you could do this. It's entirely up to you. What I'm going to do is look at the proportional sides. I can say now that y over 9 will be the same as these two corresponding sides. And I'm going to set this up. So what we'd have is that. So the equation that I'm going to write now, given that these are proportional, is that this length over this one, which would give me the scale factor, will be in the same ratio now as this one over this one. We need to remain consistent. So what I'm going to do is say that that is going to be 10 over 12. If you wanted, you could have gone the other way. It's entirely up to you as long as you stay consistent. So what I'm going to do now is multiply up, and that is going to give me that y, multiplying both sides of the equation by 9, is going to give me 90 over 12. So all I'm saying now is that y over 9 has got to be the same proportion or the same ratio as 10 over 12. So all we'd need to do is work this out. So 90 divided by 12. So 90 divided by 12 is going to give me 7.5. So we end up now with y is equal to 7.5. If we think about that, does that seem reasonable? Well, let's just have a look. The scale factor here you can see has scaled up, so we'd have 12 over 10, which does work nicely. Could have you done this differently? Well, yes, you could say that y over 10, so let's put this here, y over 10, so this side now over this one must be in the same ratio as that one over that one. It's entirely up to you. You will see exactly the same happens. Y, this time multiplying both sides of the equation by 10, will give us 90 over 12, and we can see the same. So we can say y over 9 is the same as 10 over 12, or y over 10 is the same as 9 over 12. I didn't take this side because we'd have two unknowns. If I chose 5, I'd have to have x. And if we have 5 and x, we can't, y and x, we can't solve that equation. So let's go ahead now and find the value of x. So if I look, I can say that x over 5 must be the same as 12 over 10. So if I just write that out, let's do that one just here. So x over 5 must be the same as 12 over 10. We can't have that it's 10 over 12 because that breaks the proportionality. You're choosing the wrong side. So x over 5 will be equal to 12 over 10. Multiplying up, 5 times by 12 is going to give me now 60. So we're going to have 60 over 10, and we can say that x is equal to 6. You might have already spotted that from the previous part. I never use the value that I found in the last part of the question just in case it's wrong. If I'm forced to, I will do, but if I'm not going to. We could have gone the other way. We could have said now that x over 12 will be equal to 5 over 10, and this might be slightly more intuitive. So x over 12 will be equal to 5 over 10, and we can see from this ratio now is just scaling up by 2. So we could have said that's going to half, and we can see that that is going to give us 60 over 10, which is 6. So you might have already said, well, actually that's going to be double. I should have spotted that really, and that therefore is going to be half. And if we look at that, we have the ratio. So that now works out for us. So don't be afraid to use a range of different techniques. Okay, let's try some more here. Are any of these look any different? Okay, let's just do this one and we'll go from there. Now I can see here these angles correspond, this one corresponds. So what I could say then is that if I'm scaling this up, I could say I've got a 1.5 scale factor to get this, so I need to do a 1.5 scale factor to get that one. I'm going to make a prediction that this length is going to be 6. Alternatively, what you could say now is that 9 over 6 must be the same as y over 4. This is 1.5 times bigger, so this would be 1.5 times bigger than that one. But if you're unsure, again, you can set up an equation. So let's go ahead and solve for y. So we can say now that y over 9 must be equal to 4 over 6. So this is one of the ways that you could do it. Multiplying both sides by the 9 times by 4 is 36. 36 divided by 6 is going to give us 6. So with these nice numbers, perhaps we should be spotting, perhaps I should have spotted the first one. So I could have done it that way, or I could have said now that y over 4 was the same as 9 over 6. If we look at x, what we could say for x is that x over 7.5, so if we look at that one, x over 7.5 is going to be the same as 4 over 6. So 4 over 6. So if I multiply that up, what's that going to give me? X is going to be 7 times by 4.5, which is 30 over 6. And we can see that x is going to be equal to 5. Did we expect that? Well, yes, we did, because this is simply being scaled up. So each of these lengths now, this is going up by 1.5. This one we saw is going up by 1.5. Therefore, this one right here will be going up by 1.5 too. And of course, if we divide 7.5 by 1.5, we get 5. So if you can spot them, do them. If not, set up these equations with the proportional sides. Okay, let's look at this one right here. Now this one is quite a bit different. What we've got here is the following. We've got this angle here and this angle here. Those are going to be the same. So what I'm going to do is look at this a couple of different ways. Now the way I'm going to look at it is to take this triangle and put it down here. You certainly don't need to. Often I like to think of this as a pivot point and to turn the triangle round. If I did that, what I'm going to have is the following. So this is the smaller triangle, turn round. You certainly don't have to look at it that way. You could see these now as alternate angles and these ones as alternate angles and this as an opposite angle. So what I'm going to have then is the following. This angle is going to be just here. So I'm going to have now, if I turn this around, I'm going to have the y just here. I'm going to have this angle just here, and I'm going to have the x here. I've got that this length is going to be 3. So if we look at this right now, we can see on here that I have this turned around. Alternatively, what you could do, and I don't know, it's entirely up to you if you want to view it like this. Let's just put that there. If I turn that triangle on itself, and we'll put it like so, let's do that, then this is going to be 3. We've turned this round, so this is going to be the y, and this is going to be the x. I know some people like it like so. I prefer to see it like this. Okay, so what have we got? Well, we've got the 3 and the 8. So I'll just clear that off from there. So what I need to do is find x and I need to find y. So from this I can say now if I wanted to find y over 4, so y over 4 is going to be the same now as the 3 over 8. I'm just taking now the corresponding sides. So multiplying both sides by 4, we're going to have 12 divided by 8, which is going to give us 1.5. So y is going to be equal to now what's that going to give us? 1.5. Let's just check that. So y is going to give us 1.5. With that one again, you might have spotted now a different ratio to go with that was slightly easier. If we now look at x, we can say that x over 6, and you might already be using this proportion that we have to begin with. I'm just going to say now that x over 6 is going to be equal now, and I'll write it this side, x over 6 is going to be equal now to our value right here, and we can say that that's going to be 3 over 8. So all I'm doing is taking now the sides. That one over that one is the same as that one over that one. So 3 over 8, and we can multiply both sides by the 6. That's going to give me now 18 over 8. So 18 over 8 will give us x. So if we put that through a calculator, 18 divided by 8, and that's going to give us now 9 over 4, which is 2.25. So you can use the proportion that you've already found or just set up these equations. Alternatively, what you could have said is that x over 3 will be equal to 6 over 8. You might think that's slightly easier because that's going to give us a scale factor of 3/4. 6 over 8 is 3/4, so x over 3 will be equal to that. Entirely up to you. Okay, let's have a look at this one just here. So with this one, if you like, you can now just think about flipping this over. So what I'm going to do is just flip this over, and I'm going to just redraw it. You might not need to do this, but again, it's entirely up to you. So what I'm going to do is put my double angle here. This is going to be my x. I've got now this angle, and I'm just going to put on that this is the triple angle. So if I put the triple angle, and I just put this on here as well. So let's go ahead, put the triple one there. So that's the triple one. So the triple one is there, and the triple one is going to be just here. So this time we've got something that's very slightly different, but we can go ahead and label this up. If we look, this is going to be the 6, so let's put the 6 just here, and this is going to be the 4.5. Alternatively, you can just take this as a pivot point and lift it over and put it just here. So if you wanted to do that, what we'd have, let's just put that there, we'd have this scenario where I've taken that triangle and just put it here. This one will come here, that one will come here, and then we will have similar triangles. Hopefully I'm giving you enough different ways to look at these, because I appreciate some people will be saying, well, actually I prefer to do it this way, and others prefer to do it a different way. Now with this one, we can see now that we have 6 and 8. So if you wanted to, you could say that we've got now something 3/4 of the size. If you're still not happy with that, we could go ahead and just set up the equations. So if we wanted to solve for x, we could say now the following. We could say that x over 9 will be equal to, and I'm not going to choose these sides because I've got an unknown, will be equal to 8 over 6. Multiplying now both sides by the 9. 9 times by 8 is 72. 72 over 6. X is going to be equal to 12. So does that seem realistic on there? Well, let's have a look at it. Have I done it right? The answer is quite clearly not. What I've done here is ended up putting this the wrong way round. So if I'm going for x over 9, I need to do 6 over 8. And hopefully by seeing this answer, we should think, hang on a moment, that can't be bigger. So the error that I've done now is to put the wrong sides over each other. So if we do that, this should be now 6 over 8. So that's going to give me that x is going to be 54 divided by 8, and we can go ahead and find that value. So if we do 54 divided by 8, 54 divided by 8 is going to give me now 6.75. So x is 6.75. And that looks a lot more like it. What I could have said at this stage instead was x over 6 is going to be the same as 9 over 8. Entirely up to you on how you want to set that up. You might see that that is more intuitive to go that way. It's the same as that one over that one, rather than this one over this one is that one over that one. So let's now do the next one. What we can do from here is the following. We're going to have y. We need to find y. So I could say now, entirely up to me. I've got these are already given to me. So I could say y over 8. So y over 8 will be the same as 4.5 over 6. So 4.5 over 6. So we're going to have now that y is going to be equal to 8 times by, what's that going to give me? 8 times by 4.5, which is going to give me 36 over 6. And y is going to be equal to 6. So if we look at that, that seems pretty good. Y is going to be equal to 6. Alternatively, I could have just spotted the proportion and scaled up. If we went another way, what we could have said is that y over the 4.5 will be equal to, so this time I'm saying that one over that one must be this one over this one, which is going to be 8 over 6. You'll see it will give us exactly the same algebra. 4.5 times by 8 is 36 over 6, and of course that gives us 6. You might still be using the symmetry or the proportion that you found in the last part. That is perfectly fine. With this one, just out of interest, I'm just going to draw this on. If you wanted to look at it this way, we would flip this over. We can see now that this one is going to give us the line here. So this is going to give us this angle. So that would be the angle here. This one would be the 2. This would be the double angle, and this one would be the 3. So you can work that out from there if you like. Okay, let's have a look at some of these. Okay, let's look at this one right here. Now with this one, we can view this a couple of different ways. The way I like to think about this is to split it up. You certainly don't need to, but it might help. So what we're going to have now is the smaller triangle, and then we're going to have the larger triangle. So if you want to do it like this, you can do. If I look at this now, what I've got are the following. We know that these are going to be parallel. So this angle will be the same as this one will be the same as this one, and of course these are equal as they share that. So we've got now the 7.5, we've got now the 3, we've got 10, and we've got now the x. So I want to find x, and I can choose from here. I could say that x over this side right here, 7.5, will be equal to 10 over 3. So if I do that now, let's go ahead and multiply both sides now by the 7.5. X would be equal to 75 over 3, so x is going to be 25. Should I have spotted that? Well, if I haven't, it's not a massive issue, is it? If we look at this now, that is going to give me the value right here. If I'd gone a different way and said, well, actually, let's just say now that x over 10, so x over 10, I'm looking at these two sides, must be in the same ratio or proportional to the 7.5 over the 3. 7.5 over 3 is going to give me 2.5, so this would give me now 10 lots of 2.5, which of course is going to give us x is equal to 25, as we expected. So either way round with that one. You might want to split it up, you might not. You go for it, entirely up to you. Okay, with this one, let's just do this one. Let's go ahead and sketch this up. So what we'll have is the big one and the small one. So there's the big one, and then we'll have the small one, and we can put these on, and it will look something like so. So these don't have to be immaculate. We know that these angles are going to be the same. This one is that one. We can see we've got parallel lines here, and we can put the information on. So what I've got then is a 5. I've got a 4. This one right here, the whole thing is going to be x, and this one is going to be 5. So if we look now, we know that this angle quite clearly is the same as that one. They share this one as it's on top of one another, and we've got the right angle. So we can say it's entirely up to us on this. We can say that x over 5, so x over 5 will be equal to 5 over 4. So that's going to give me, multiplying both sides of the equation by 5, 25 over 4, which is 6.25. So 6.25. Or if you like, you can leave it as 25 over 4 as an exact fraction. Alternatively, what we could have done is gone this way. I mean, we're going to get the same values. We could have said x over that one is the same as that one over that one, and it would give us the same numeric values. It would just be a different equation. So that's quite nice and easy. Okay, let's look at the next one. The next one is quite interesting because this one is very slightly different. Let me draw now the small one, and then let me draw the large one. We have to make sure we don't fall into a trap here. This one now has got 12 here, so we've got 12 and we've got 10. This time though, we've got 27. It's not just for 15, it's for 15 and the 12, and we've got x here. So we know these ones are the same. We know this is a right angle. They're all parallel. We know that this top angle is going to be the same. I certainly don't need to put these angles on. I'm just doing it for completeness. So what we can say from here, entirely up to us, we could say that now x over 27 must be now in the same ratio as 10 over 12. Or I could have gone the other way and said that x over 10, so looking at these corresponding sides, will be the same as 27 over 12. So that's going to give us now on here x is equal to both sides either or 270 divided by 12, and we can go ahead and put that through the calculator. So 270 divided by the 12, and that's going to give us now 22.5. So x is going to be equal to 22.5. Is that realistic? Well, yes, it is. And we can put that on, and we would have to give the units, of course. I've not put the units on, but that would be, of course, in meters. So there we go, some work with similar triangles. Hopefully you can see lots of different approaches to doing this. I think we'll just do a couple more questions and just have a go from it. Okay, so if we look at this one right here, we've got now two parallel sides. So using alternate angles, we've got this one now is going to be the same as this one. And remember, z angles or alternate angles, that's going to be the same. And then this one is going to be the same as this one, they're alternate angles. And then, of course, we've got opposite angles, which are going to be equal. So instead, what I could do is redraw the triangle below, entirely up to me. If you don't spot it this way, that's perfectly fine. What we're going to have then is the following. If I just put these angles back on, this one is going to be now the green one. We're going to have now down the bottom, if I put this one on, this is going to be the blue one, and then this one over here is going to be the red one. So if I put the dimensions on, what we're going to have is the 7.2. So we've got the 7.2, we've got the x, which is going to be just here, and we've got the 8. So all I'm doing is focusing on this triangle and this one just here. So we can see now that the proportional sides are these two, and then the top and the bottom. Hopefully you can see now that there, and I'm not even going to, well, I will, we can see that this one is twice the size, as we've got these side lengths will be proportional. But let's pretend we didn't spot that, and let's just go ahead and look at finding the values. So on this one, what we can say then is x, so we can say then that x over 8, if we like, will be equal to 4.6 over 4, so 4.6 over 4. If I multiply both sides, what we're going to end up with 8 over 4 is just 2, and that'll give us 2 lots of 4.6, as we expected, which is 9.2. We know that it's double the size. We can see that from here. A common error is, we can see it quite clearly from here, that people equate these two as the corresponding sides. It's not. So hopefully you can see from there that's going to be nice and straightforward. So all we would do is simply plug this in and go ahead and find y. Hopefully you can see that that shouldn't be an issue. We're just simply going to get half of this value right here. With this one, I'm just going to label this up. So we've got two parallels. So this angle here will be the same as that one just there. We can say now that this one just here is going to be the same as this one just here. And we're going to have this shared angle in the center if you turn it round. So we can see now that the corresponding sides are going to be on here. We're going to have the 30 and the 18. We're going to have the corresponding sides of the y and the 12. And we can see from here now that our other ones are going to be the x and we're going to have the 20. So if you want to look at it like that, you can do. So if I wanted to at this stage, what I could say now is that x over 20 will be equal to now the 18 over 30. There's no point me going for now the 12 over y because we don't know what y is, and that would leave me now an equation with two unknowns. So I'm going to say that that is going to be 18 over 30. So if we now multiply both sides by 20, we're going to have 2/3. The 10s are going to cancel. 2/3 of 18, and x is going to give me on there 2/3 of 18 is going to give me 12. That looks pretty good. So that is going to be now 12 centimetres. And you can kind of see from here as well that that's the level of proportion. And again, for y, we could just use this fact or use another one. So with this one, no different to what we've looked at before. Split it into two triangles if you like, and simply go ahead and solve. So there we go. Similar triangles, different ways of looking at them. You decide, you find which approach you like best, whether you're spotting that proportion early on and using it, or whether you're setting up an equation, whether you're spinning the triangles around like so, it's entirely up to you.